of the function and then differentiate the function. You haven't done this for a long time, right? Domain. So we have f of x equals to 1 divided by 1 minus ln x minus 1. We have a denominator. So the first thing that people point out is, well, the denominator cannot be equals to 0. All right, you're correct. 1 minus ln, the denominator cannot be equal to 0 because 1 divided by 0 is undefined. And then we solve this equation, subtract 1 on both sides, and then divide both sides by -1 or multiply both sides by -1. That is equals to 1. And then how do you solve that? So this one is what? This one is e to the first power equals to x minus 1, and then e minus 1 is equals to e minus 1 is e plus 1 is equals to x. So they are all cannot be equal. Then we have x cannot be equal to e plus 1, right? So x cannot be equal to e plus 1. So which is x cannot be equals to 2.7 plus 1, around like 2.8. So that is the first restriction. And then the second restriction, what's the second restriction? For Ln, what is the graph of Ln? The graph of Ln looks like this, right? The graph of Ln, we have an x-intercept right there. So this is the graph of Ln. So this is a vertical asymptote at x equals to 0. So the graph of Ln is x has to be greater than or equal to 0, right? Since this is a x minus 1, then x minus 1 has to be greater than or equal to 0, and x has to be greater than 1. So let's box all the restriction. Is that all? There is one more. So you have 1 minus ln equals to that. So what is the other one? The other one is x minus 1 cannot be equals to e, because ln e is equals to 1, and then you have 1 minus that ln is equals to 0. But this one is repetitive, right? X cannot be equals to e plus 1, which is something that we already take care right there. All right, so the domain is done. So we have this, and then we have that. Let's summarize the domain on a number line. So we have a number line. Here is how number line works. We have 0 in the middle, positive number on the left, negative number on the right. So 1 is right here, right? And then the e plus 1 is around right here. So x cannot be 1. We draw an open circle. X must be greater than 1, cannot be e plus 1, so greater than 1 is the right hand side. And then we make a jump at e plus 1. So the domain is using interval notation, that is from x equals to 1 to e plus 1, and then open parenthesis from e plus 1 to positive infinity. We use open parenthesis because x cannot be equal to 1 and cannot be equals to e plus 1. And then for the infinity, we don't know what exactly that value is. We always use infinity. All right, the domain is done. The next thing that we have to take care is the derivative. So this one, we have to use the quotient rule. So that is gf prime minus fg prime divided by g squared. Let's do it. So we have f prime of x. First, I square the denominator first. So that is 1 minus ln x minus 1, the whole thing square. And then g, I copy g. 1 minus ln x minus 1, that is the entire denominator. And then the numerator is a 1. So since the derivative of 1 is 0, then you have a big 0 right there. And then the minus for the quotient rule. And then you copy the function g, function f, which is 1, and then derivative of the bottom. The derivative of 1 is equals to 0. And then minus ln, you have 1 divided by the whole thing. And then the derivative of the parenthesis of ln, x minus 1, the derivative is 1, so we don't need to write that. That would be the f prime. So f prime of x is equals to, this is a 0, right? So this is gone. And then we have plus, right? 1 divided by x plus 1 over this minus 1, and then square that. So this will be 1 divided by x plus 1 times 1 minus ln x minus 1 square. So that is your derivative. And then I know we have an ln in the denominator. What if you have ln in the numerator? What's the domain? So let's discuss a quick problem. Let's discuss another problem. This problem, I will only show you how to find the domain, but we are not going to do the derivative. So let's say you have f of x equals to ln 2 minus x divided by x plus 5. So this time we have an ln on top. How do we find the domain? So first, the denominator, the x plus 5 cannot be equal to 0. So x cannot be equal to negative 5. And then on top, we have 2 minus x greater than 0. So negative x greater than minus 2. Subtract 2 on both sides. And then when you multiply or divide both sides by negative 1, you have to reverse the direction of the inequality symbol. So these are the two restrictions. And then we have a number line, negative 5 and a 2 must be less than 2. So, and then we have to skip negative 5. So the domain is from negative infinity to negative 5, and then from negative 5 to positive 2. So that is another domain problem that I would like to discuss. The next problem that I would like to discuss is a tangent line problem. So let me go ahead and paste that problem right here. So this is our tangent line problem. Let's read the problem. Find an equation of the tangent line to the curve at the given point. So we have an ln function. And then I want to find a tangent line. Alright, so to find a tangent line, what's the first thing that we have to do? Is we have to take the derivative, right? So ln, we have the whole thing in the denominator. And then times what? Times the derivative of the quantity, the function inside the parenthesis. So what's that equal to? The derivative of the x squared minus 3x plus 1, that is equals to 2x minus 3, right? So that is my slope. So y prime equals to that. This function describes the slope of ln at any x value in the domain. Again, that y prime describes the slope of the given function at any x value within the domain. If you are looking for a specific point, 3 comma 0, alright, then x is equals to 3, then the slope is equals to 2 times 3 minus 3 divided by 3 squared minus 3 times 3 plus 1, that is equals to 6 minus 3 divided by 1, the slope is equals to 3. This one is the slope of the tangent line. At that point, 3 comma 0, the slope of the curve is equals to 3. How about the tangent line, the straight line touching 3 comma 0? Tell me the equation of that straight line. We have to use a point slope form. So y minus y1 equals to slope times x minus x1. Y minus 0 equals to 3 times x minus 3. So overall, you have y equals to 3x minus 9. This is the equation of the tangent line. It's a straight line touching the curve of ln at the given point 3 comma 0, and this line has a slope positive 3. Alright, that will be all in this part. I will see you all in the next part.